Hey, let's look at the mesh current analysis. Before we do that, we first want to look at how the mesh currents are related to the element currents, which is based on my experience, this could be very confusing point to some of you. Okay, pay attention to this, and so we can get the thing cleared up. Let's see what the mesh currents here. I have very busy charts, so there are several meshes or loops. So we have this I sub 1, I sub 2, and I sub 3, so on and so forth, and I sub 6. So these are the mesh currents in each mesh. We assume there are currents flowing around this mesh, right? Around this mesh, of course, through these elements. So of course, some of the elements, let's see if this element Z sub 10, and this element is shared by two meshes, and there will be two mesh currents flowing through these, right? So I would like to show you how these mesh currents are related to the element current, because in the end of the day, we are interested in element currents, right? So if we know the element currents, we know the element constraints, and we know the element voltage. So we want to solve the circuit. We basically want to know all the element currents and the element voltages. That's the end goal of this game. And if you know the element currents, but the reason we don't want to solve the element current directly, because there are too many equations to solve if we do that. And instead we want to do the mesh currents, and there are less numbers. So you see we only have 6 mesh currents, right? If you solve this equation, you have, you may, how many? I have 13 elements. So that means you, instead of solving 6 equations simultaneously, you may need to solve 26 equations if you use the element constraints. That's 13, and KCL and the KCL equations. I think the KCL would be 7, and the KVL equation would be 6. So you have 26 equations to solve simultaneously. Anyway. So let's see, look at the element currents and the mesh currents. So let's start with the easy ones. The easy one I'll call the outer one. The element is not shared by the meshes, right? So let's see on the outer side of this drawing, right? So let's see 1, 6, 11, 3, Z sub 8, and Z sub 13. Those elements are not shared by two meshes. They're only in one mesh, right? So in this case, I can write the element currents. So this is type 1. This is type 1 is this element currents I sub Z1. I sub Z1 is just equal to, so I sub Z1 is going to be equal to negative I sub 1, right? And I sub Z3 is equal I sub 2, because they are in the same direction. And I sub Z6, I sub Z6, that's equal the negative I3, right? The I sub Z8, and that's going to be equal to I sub 4, right? So with this, I think this is type 1. This is type 1, the easier one, right? So let's go a step further, called type 2. And type 2, I normally didn't go in this much detail, but I think it's worth it. Let's see the number 2. In this case, I will go. These elements are shared by some, shared by the two meshes, but they also, one end of this element is also connected to the other node. So let's see the node A, B, C. That's very outside of this, very outside this circuit, right? So let's see, in this case, I sub Z4. Now I can write the KCL equation, right? So the KCL equation for I sub Z4, that's the leaving currents. That should be the sum of the entering currents, which is negative I sub Z1. No, the entering currents are I sub Z1 plus. And the entering currents from the Z sub 6, that's a negative I sub Z6. right? So I sub z6, and if we look at the equations, and in this case I sub z1 is equal negative I1, right? So in this case I have a negative I1, and negative I sub z6, that's equal negative and negative, I get a plus I sub z3. So in this case or you can write this way, this I sub z3 and then minus I1. You can do the same thing for the I sub z2. So the I sub z2 is going to be equal to, let me keep that shown, but let me move to this space here. So I sub z2 is going to be equal I1 minus I2, and I sub z5. You can do this yourself and make sure you understand. So in this case, I sub z4 minus I sub z2. And so this is type 2. Okay, the type 2 we have this 3, and then the type 3. That's probably the most complicated one. Is that type 3? The type 3 is the I sub z7. The I sub z7, this is the kind of inner elements, right? So this is shared by two meshes, and neither of these nodes is connected to the most outside node, right? So this is the so in this case we can still write the KCL equation at node number D, and in this case, and I sub z7, that's the leaving currents, right? So that should be the sum of entering currents, which is I sub z4 and plus I sub z2. I sub z2 also entering this node, right? And the I sub z5, that's a leaving, but we need an entering, so we plus the negative I sub z5. And that's the KCL equation. And see if we can utilize the type 2, the equations to replace with the mesh currents. And in this case, let's see, the I sub z4, that's the I3 minus I1, right? And I sub z2, and that's the I3, and I sub z2, that's I1 minus I2, right? The z sub 5, that's negative, so that's a negative I4 minus I2. Okay, let's see if we can work this out. And so let me, if I can change the color. Sometimes I can, sometimes I can't. Okay, I did. So in this case, let's see if we can work out this out. So this is negative 1 and this is positive 1, those will be cancelled, right? And also this is negative I sub 2 and negative, so this will be cancelled. And what we are left with is I3 and minus I4, right? So let me change it back to the blue color I had. And in this case, I can move this up. And in this case, I would have I3 minus I4, right? So if we observe the different type, if we observe all these equations, right? So we can kind of find a common feature here is, let's see, if I sub z7, that's equal to I sub 3 minus I sub 4. I sub 3 in the same direction as the I sub 7, the reference mark, right? I sub 4 has opposite direction because this is clockwise, so this go up. This goes up through the I sub 7, through z sub 7. So in this case, we'll always have, if we have the mesh currents kind of going in opposite direction through the elements, we always use the mesh current that's in the same direction as the element currents minus the mesh currents that's in opposite direction, right? So if you label this, if you have, let's see, if you label, let's see, this element I, and if you have I sub x and I sub y, so let's see, if you choose one mesh in the clockwise direction and the I sub y in the counterclockwise direction, in this case, I mean, I is just equal I sub x minus plus I sub y, right? So you see this effect, right? So the most intuitive understanding of this is like, let's say in the river, right? So the total currents would be equal to, you may have two streams of this currents, one in the same direction, the other one in the opposite direction. So the total currents, which is the element currents, is actually equal to the sum of these two, means the one in the same direction of the positive, and the other one is in the negative. So you add these two, or you subtract the negative one from the positive one, and you get this one. But if you these two streams in the same direction, you add them together, right? And also, if these two are in opposite direction, let's see if you have another case. Let's see if you have I1 and you choose in this IX and this IY. So this is the one in the clockwise direction. And in this case, I1 is going to be equal IX plus IY, but you need to put a negative sign in front of this, right? So that's in front of this I sub 1. So you know the element, how this element really connect to the mesh currents. Hope you got the idea, although I went a little bit longer than necessary. So next we're gonna take a look at how we formulate the mesh current equations.